So the Gauss law for electric field, or in differential form, you're having divergence of electric flux is equal to the charge density. So this is in Coulomb per meter cube. This is in Coulomb per meter square, and this is per meter. So dimensionally, it is consistent. That means the net outgoing flux, the net outgoing electric flux is equal to the charge enclosed. This guy is equal to the charge enclosed, the total charge enclosed. If I have a Gaussian surface like this, let's say it's enclosing a charge, then this guy, the divergence tells you the amount of source or sink. If it is positive, then there is positive charge inside. If it's negative, then there is negative charge inside. If it is zero, then there are equal number of positive and equal number of negative charges. So they cancel each other inside the volume. The same concept for magnetic field. In differential form, divergence of B is equal to 0 because there is no magnetic monopoles. The north and south poles always appear together. So the same thing analogous to this guy in integral form. If I have to take a closed surface, if I have a bar magnet from the north to the south, you have the field lines like this. If I were to take any surface S, what goes in should be equal to what comes out. Now, how about Ampere's law? Ampere's law says that if you have a current carrying conductor I, then there's going to be a magnetic field around it, given by the fingers of your right hand, how they are curled. So the curl of the magnetic field, in fact, the curl of the magnetic field is in fact equal to the current density. So this is in amperes per meter square. This guy is in amperes per meter, and this is per meter. So current density is in amperes per meter square. So the same thing using Stokes' law. So this is Stokes' theorem. By using Stokes' theorem, you can see the differential form. This is differential form. This is integral form. The circulation of the magnetic field is equal to the current enclosed. This is C, and if there's a magnetic field, if there's some currents that are coming out, I1, I2, I3, then what is the total current enclosed? It's exactly the same thing, the Ampere's law. Faraday's law is, if I have a single loop, then the voltage that is induced is going to be negative dphi over dt. The electromotive force is minus dphi over dt. But then to get the differential and integral forms of Faraday's law, you just do this additional step where the voltage is equal to the circulation of the electric field. This is what we read in electrostatics as well. Yeah. Because of that, you notice that this guy over here, the curl of the electric field, should be equal to the change in the magnetic flux. So this I can always write as minus integral S dou B over dou T dot ds. I can interchange the order of differentiation and integration, because integration is in space, differentiation is in time. So I can swap space and time. When I do that, this term becomes exactly this term. So curl E is negative dou B over dou T. This is exactly the same as the Faraday's law, but just writing it in another form.